Hello, welcome to this video. So this video will be about a conventional question in paper 1 of the ESE about loci, about equation of circle, okay, about centers of triangle. So here let A, okay, so A represents the area, and then P represents the perimeter of radius R. So triangle CDE, and then A and P are area and perimeter of triangle CDE respectively, and the radius of the inscribed circle. So it's about the inscribed circle, CDE. First of all, we have CDE, CDE. So part A, CDE, and then we have the inscribed circle. Okay, so here the radius R. So you can see how to do it. So the trick. Okay, so we'll be trying to do this. So of course, due to tangent perpendicular to radius, so all these are right angled, and then we will try to draw these 3 angle bisectors, and then we'll have V regions. Okay, so and then this, and then this. Okay, so that's why here, don't forget all these are radius of the radius of the inscribed circle. Good. Okay, so that's why here, so we have 3 triangles. We try to calculate the areas of these 3 triangles respectively. If we take DE as the base, then the height, okay, of the triangle at the bottom, so there will be Alu. And then for the green triangle, if we try to take CG as the base, then the height will be Alu. And then similarly, and then sum them up will be equals to the area, and that will be A. Okay, so and then we try to take out the common factor R and multiply both sides by 2. We get R times the sum of the V sides of the triangle, so that would be perimeter, and that's why we have PR equals A. No, equals 2A, I mean. Okay, multiply both sides by 2. So that's why we can prove like this. Okay, so that's all for part A. Good, now we go to part B1. So the coordinates of points H and K. H and K. So again, 2 points here. So H and then K. 14, 0. So H will be above K. H will be somewhere here. And then K will be somewhere there. That will be 14, 0. Good. And then let P be the moving point, the rectangular coordinate of such a perpendicular distance from P to OH. Where is O? Where O is the origin. Okay, come on. And O is 0, 0. So OH, P to OH. OH is here. And then P to HK. HK is here. Okay, good. And then P. So where is P there? So P will be here. Okay. So what's the geometric relationship between gamma and angle OHK? Now you can see angle OHK, so this angle, and then you can see this is gamma, and then along gamma I just try to randomly pick some point P. So the distance between P to HK and from P to OH must be the same. So that's why here gamma is actually the angle bisector of OHK, angle OHK. So that's why we need to put down O gamma is the angle bisector of angle OHK. So that's for B1. Good. Okay, so here comes the last part, B2. So find the equation of gamma. So you can see it's about angle bisector. So you can see actually gamma would be this line in part A. So that's why we can try our best to use the results from part A. So find the equation of gamma, which is a straight line. So and then here so we just try to replace CDE in A with OHK. And that's H, that's K, and that's H. 9, 12. Okay, so gamma. Good. So that's why here we erase this. And then we know angle bisector already. That's good. So for finding the equation of gamma, which is a straight line, no, it's angle bisector, but still a straight line. Straight line equation, we need one line point. So already we have, that would be point H. But we need slope. We do not have the slope. Okay, so that's why here we need the we need the in-center. We need the in-center. Okay, so that's why the in-center, I try to let it to be G. How about that? This is G. Okay, so if we got G, okay, then we would have 2 points, and then we can calculate the slope. Okay, so that's why we need to find G, and then G will be vertically above OK. So if we know R, so that will be right. If we know R, then no, we still have to find the two coordinates, right? We still have to put, okay, never mind. First of all, shall we find R first? So how to find R? So here OH. So this triangle, in order to find R, so we need to use PR equals to A, right? We need to use PR equals to A. So up to now, P is not known, A is also not known. But here you can see the 3 points are all given. So that's why we try to find OH. That would be 9 squared plus 12 squared. So that would be 15. And then HK, that would be 14 minus 9 all square. The distance formula, and then plus 12 square. And that would be 13, am I correct? Right. And then Oh right, the area can be easily found. Well anyway, so PR equals to A. So P, so that will be 15 plus 13 plus 14. So this is 14. No need to use the distance formula. R and then 2A. A, so we can take 14 as the base. And then the height will be 12. Okay, so and then R equals 4. R equals 4. And then with R equals 4, then G, we know that that will be, the Y coordinate must be 4. The Y coordinate must be 4. So let's say H4 or G4, maybe. Okay, so we try to suppose G to be G4. Okay, so and then if G, so that is G4, so that means this part is G. So in that case, this part will be 14 minus G. So using a tangent property, so this part would be 14 minus G as well. Okay, so and then after that, right, so and then this part is also G, and then this part will be 15 minus G. So where's 15? So that will be OH, calculated before. So then this part will be 15 minus G. So that's why here, we try to make use of HK. So HK, that will be defined above. The length of HK is 13, and then HK now is consists of two parts. So 14 minus G and plus 15 minus G. So here we can solve the G. So 13 equals 29 minus 2G. So that's why 29 minus 13, so that will be 16. 16 divided by 2, so that will be 8. So now we got like 4. This is very, very important. So we have x4, and then we have 9, 12. So then we try to find the slope of gamma. So that would be 12 minus 4 over 9 minus 8. And that will be 8. And then the equation of gamma, which is y minus 4 over x minus 8 equals 1. So that's why x, so that will be x minus y minus 64 plus 4, so that's why minus 60. Okay, and that's all for this part, as well as the whole video. Thank you for watching.